Hello everyone, welcome back. So in this video session, we are going to look at how to implement parity check. So all of you know parity check is one of the error detection technique. So this is the program for parity check and it is implemented in Java. So first of all, before explaining about the program, let's look at the output of this. So compiling the program. Okay, now executing the program. Okay, so it is asking how many bits you want to send. So this is the data that we want to send to the receiver. So I am giving 8. Okay, so now I have to enter the data which is of 8 bits with spaces 1 0 0 1 0 0 0 1. So this is the 8 bits that I want to send. Okay, it is saying the original data to be sent is, so you can see here it has added an extra bit. This is the parity bit, and in the program we are implementing even parity. So since the number of ones 1 2 3 is odd, so we are adding the parity bit as 1, which makes the total number of ones 4. Okay, right, now it is asking enter the bit position to change it. Now, so what is the use of this is, so we want to check whether the data is received correctly or not. So to simulate errors, we are going to change or flip one of the bits. Okay. So let's say I want to change this one, this 0 into 1. So I am giving the index value, okay, as 2. Right. So you can see here the data that was sent to the receiver is this one. So you can see the bit at index number 2 has been changed from 0 to 1, and the technique found out that an error is there and it is saying data is corrupted. Okay, so it actually detected there is an error. Okay, so now let's look at the program. uh, so we have imported two Java packages. One is java.util, this is for the scanner class, and java.io, this is for the buffered reader class. So both of them are for reading input from keyboard. So for those two classes, we have imported these two packages. So let's move on to the main method. So here is the main method, and it throws IO exception if there are any. So you can see here, it is asking a print statement for prompting the user, and we are creating scanner class object here, and we are reading the number of bits into the variable b. Okay, so based on this b, we are creating an array of size b plus 1. So what is the use of this extra bit is, this is for parity. Okay, so the b bits will be storing the data and the plus 1 bit will be storing the parity bit. And again a print statement for prompting the user to enter the data, and for reading the data, that is the binary numbers, we are using buffered reader, and whatever data we have entered, that is this, we are going to divide it into bits, individual bits, by using the string tokenizer class. Okay, we are going to use string tokenizer. So this is also present in the java.util package. Okay, including scanner, this is also present in java.util package. And we are taking a variable I and we are using a method has more tokens, which is available in string tokenizer, and we are adding bit by bit into the array data. Okay, so this next token method gives the data as a string, so we are converting that string into integer by using integer dot parseInt, and finally storing it into the array data. Okay, now once we have the data stored in this array, we are counting the number of ones in that array. Okay, and if that count is even, so this method is written here. So here is the is even method, and also on top of that we have one other method for counting the number of ones in the data. So this is going to return the count of number of ones, and this is going to check whether that count is even or not. Okay, right. So coming back, so if the count is odd, okay, so this condition is going to be true when the count is odd. So as we already discussed in the technique, if the number of ones in the data is odd, we are going to make it even by using this one. Parity bit is set to 1. Otherwise the parity bit is 0. Okay, now we are displaying the data that is going to be sent to the receiver using this code. And next we are going to simulate the error. So we are asking the user about which bit he or she wants to change. So this is for reading the bit position which the user wants to change, and we are flipping that bit based on the input given by user. And then we are finally displaying the data that is going to be sent to the receiver. Okay, and finally we are going to check, we are going to compute the parity bit again at the receiver. Okay, so this is another user defined method which is at the top. So here it is, check even parity. Okay, so it is again going to compute the parity bit and it is going to return that bit. And now we are comparing the bit which is computed by the receiver and also the bit that is sent by the sender. If they are same, we say there are no errors, data is accepted. If they are not same, that means there is some error and we are displaying error found, data is corrupted. Okay, so this is how parity check works. It's a simple technique to detect errors. Okay, so that's it for this session. Thank you.